Today we're going to talk about solving rational equations. So let's go ahead and get started. Our first part is not going to have extraneous solutions. For extraneous solutions, look at part 2. Here's our first example. Please follow along. Notice our steps. We're going to isolate the radical, clear the radical, solve the simple equation, and then check for extraneous solutions. So we are going to isolate the radical. Both radicals do not have anything added or subtracted, so they're already isolated. So I can check off step 1. To clear the radical, we are going to multiply the exponent. We're going to raise it to the exponent of whatever the root is. These are understood to be square roots, so we are going to raise both sides to the second power. Now remember your exponent rules. If I have anything raised to the second power, that root and that exponent cancel each other out, and this radical sign just goes away. So this is going to turn into x plus 6 equals 2x minus 4. And if you notice, we have cleared the radical. And we're just going to solve this simple equation here. So what we're going to do is we are going to subtract x from both sides. 6 equals x minus 4. Go ahead and push the 4 over. So x is going to equal 10. And then let's go ahead and check that. So if I put this back into here, this would be 10 plus 6, and that should equal 2 times 10 minus 4. 10 plus 6 is 16. 20 minus 4 is 16, and sure enough, that is correct. So this is going to be the answer to this one, number 1. Okay, let's take a look at number 2. For number 2, we are actually going to perform step 1. Step 1 says to isolate the radical. The radical is not by itself. It has this minus 2 next to it. So let's go ahead and push it over to the other side. So when we push that minus 2 to the other side, it's going to turn into a positive 3. Clear the radical. This is an exponent, this is a root of 2. So we're going to raise both sides of the equation by an exponent of 2. So remember, these knock each other out, the symbol and the exponent. So you have x plus 5 equals a 9. Of course, push the 5 over. X is going to equal 4. And you could very quickly check that. Make sure you get a square root of 3. You could even check it in the original equation. All of it makes sense. So that is going to be our answer. For number 3, what we're going to do is we're going to go ahead and perform step 1, isolate the radical. So we're going to have the cube root, and then minus 7, that's going to turn into a negative 2. This time our root is 3, so we are going to raise both sides of the equation to the third power. So this is going to clear out those square or those cube root sign. Over here, a negative 2 raised to the third power is a negative 8. So let's go ahead and push the 2 over to the other side. X should equal a negative 10. And of course, when we plug this in, we would get the cube root of a negative 10 plus 2, and then minus 7 or plus 7, and that's going to equal a 5. And when we perform this operation, the cube root of negative 8, of course, is negative 2. And negative 2 plus 7 is definitely a 5, so we get to box in this answer. Let's go ahead and take a look at number 4. So on number 4, isolate the radical. That's already done for us. So remember, this is going to be raised to the third power because it's a cube root. So now we're dealing with 2x minus 6 equals x plus 4. Now we're going to solve the simple equation. So moving the x over, it's going to be x minus 6 equals 4. Of course, add 6 to both sides. And x is going to equal 10. That's solving radical equations without extraneous